In this video, we want to revise a couple of questions given this data. So one thing to notice is that here, the total SS, uh, which is here, so we can notice that it is rank. So this one is our RSS, then this one is our SSS. Then you can also notice from here that the age is not given, but in this question, we are going to assume that it's given. So this is the beta one. And here we have the rank given there as well. So we have a couple of questions we need to answer. In case you are doubting why, wondering why we have assumed this. So there's a video I'll put in the description so you can check on how to get the beta one. So let's just turn to the questions that we have. So these are the questions here. The first one is using the confidence interval approach, state and explain whether the variable age is statistically significant or not. Use 5% level of significance that give 1.96 critical value. So this is the first question that we want to start with. Let's just turn to the working board so that we can try to figure out this. So the first thing to do is just to state the hypothesis, which is just, well, let me just send my. So this will be H naught is just beta 1 0 to 0, which is just saying this has no relationship. When it says beta 1 is equal to 0, meaning between the variables there is no relationship, it's not significant, the variable that we are testing. So this one, the alternative now will say not really, there is a relationship. So it say it's not equal to 0, so meaning it's significant or there is a relationship. I'll just say ara. Let's say ara right there. So this is the first one that we need to do. So the second thing that we need to do is just to just state the critical values. So we're saying we have alpha of 0.05, then the critical of z. Z critical is given is just 1.96 right there. And the third thing we're going to do is now to compute. So we're using the confidence interval approach. So we'll say beta hat on, since it's the confidence interval approach, it's an interval, so it can be negative or positive. So we'll have positive or negative of this, which is just z critical, then multiplied by the standard error of that. Right there. So let's just plug in the information that we have. So beta naught, beta 1, is you can go back to the table and check on that. So given the standard error, if we check on the table, we just have to go to the variable h, then check the standard error that is given there. So notice that we'll have right there. So from here, we have now to compute the interval. So we just have to get a calculator. So let me just get my calculator to show you how we are moving from this point. So here is my calculator. So what we need to do is, let me first of all treat that. Then here what we need to do is, we can start with either, my calculator just disappeared. Well, comes back. So we'll have 0. So when we have that figure, we just have to round it off. And notice that we'll put it here because we were summing up. We were adding. We use a plus. So we'll put it there. 4 digits. How is it going to be? 0. Then we'll have 8 there. Just like so. So let's go on and get what is here by subtracting there. To delete. Then I'll put in those things. So 0. So we have that figure. So all we need is just to plug it in like so. we just need 4-digit numbers like that. So from here, we need now step 4, which is just the conclusion. So how do we conclude now? So concluding, if you check here, this H naught argues that there's no relationship. It's equal to 0. So we have to check in this interval. Do we have a 0 or not? Does this interval contain a 0 or not? So if you check, it's starting from 0.1. The point here. So 0.1 up there, which shows that there is no 0. So if we notice this, what we need to do is to reject the H naught. So we say reject H naught, then conclude that this is true. And when this is true, that means that there's a relationship and the variable that we are testing, the H, is statistically significant. So in a single sentence, you can just say, we reject H naught at alpha is equal to this, then conclude that the variable H is statistically significant. So let's go on and compute the second question. Now the second question. So the second question is, use the p-value approach, state and explain whether the variable S is statistically significant or not. So we don't even have to turn to the working board on this question. So with this question, if you remember the p-value for S we were given, and it was something of 0.000, just like that. So we just write that. Then alpha we had 0.05 like that. So the p-value approach, it just compares the p-value to alpha. When we have p-value less than alpha, then we conclude to say the H naught is false. So that implies that this variable is statistically significant. When it's greater, like that, then that implies that the H naught is true. Then the variable this, in that case, can be statistically not significant. But in this case, when you compare this to that, you find that the p-value is just less than alpha. So on this one, we therefore conclude that the H naught is false. Therefore, the variable S is statistically significant. So that's it for this one. Let's come now to our fourth question. This one, demonstrate how we can get the R-squared figure using the pieces of information in the table above. So we'll just work from here. Well, so this one is equal to that. And we know this, but we don't know this. So we know again that this one, SS, is just we have SS here. And this one is just SS itself, and plus RSS, like that. So in the table, we have this as well as this. So let's just plug in those figures. So then once we have this, all we need is just to use the calculator and calculate that. So let me just get my calculator. So here is my calculator. We have 74, 54.91824, and divided by open bracket. We just need to put everything in the calculator because of time. Plus 2,815.9859, like that, and close the brackets equals. So the answer we have is that, which is 0.209. So let's just round off to 6, like that. So when we multiply that by 100, we'll say answer multiplied by 100. In terms of percentages, we will have that one equal to 20.96%. So this one is a 6. So this is the demonstration of how we can get the R squared. We have one more question left. It could be someone to, not really sure. Let's just scroll down. Oh, this is our fifth question. The table above has the R squared and adjusted R squared. As a student of econometrics, well, economics just popped up in my mind, so I couldn't see that that was econometrics. But let's continue. State and explain which one is appropriate to use between the two. Favor, explain what it measures. So, which one would you pick as a student of econometrics? Adjusted or just R squared? Well, adjusted is better. And this is because R squared has a tendency of increasing when irrelevant variables are added to it. But when it comes to adjusted, it detects either by increasing or decreasing according to the significance of the variable. So I think we need to pick adjusted, then we need to explain just like what I've said. So that's it for that question. Let's go to our sixth one, which is F. Using the coefficient of the variable age of that and its standard error that. Let me just be showing you. So this is the coefficient we are talking about. Then this one is the standard error. And the question says, demonstrate how we can conduct hypothesis testing using the t.statistic approach, considering 5% significance level, which gives 1.6 critical values. But we don't have to read that. So let's go on and work on that. So we begin with the first step, which is just stating the hypothesis testing or this problem. So we'll have H naught, which argues that there is no relationship. So beta 1 is equal to 0. Then we'll have our, this one doesn't look really like a 0. Let me just swap this. And I'll say H naught of 0 like that. Then H1, which is the alternative hypothesis, this argues that there is a relationship. So this is not equal to 0 like that. So from here, it's not always the case that you'll have uh, this arguing that it's not equal to 0. Suppose, like in the question, they say that there is a positive relationship. So notice that your alternative hypothesis will be then that it's greater than 0. Because when it's greater than 0, that means you have a positive relationship. Then the other way would say it's like so, less than 0 like that. We can have this scenario basing on the kind of the question. But this question is silent about all that. So we don't know if this thing has a positive or a negative relationship. Thus, we just use a equal to. So this is our first step. So we can just indicate here that this is 1. So the second now will be just stating the critical values. So critical values at alpha is equals to 0.05 like that. So we're using a t-test, which they have told us. So this will be critical of t like that, which is just 1.96. So from here, if you want, you can even show that you have a tutorial test. So you have something of this. It's not too perfect, but hope you guys can see. So you will have a negative 1.96 here 1.96, like that. So this is your rejection region as well as that. So it will be like so. Then this is your acceptance region. So the third step now will be just now computing. So the first thing you want to recall is just the formula of the t-statistic. So this is just given by beta hat uh, 1 minus beta star of h naught. The one we have in there, this is just equal to 0. So this will be 1 like that over the standard error of beta hat 1 like that. So this is what we will have. So let's just solve this from the other side here. So if you go in that table, we were given all of this that we have in here. So what we need to do is just to plug in the information that we have. So the beta one we assume that we already have, which is just 3.3, I mean, of 930 minus beta of this, which is just a 0 from h naught, then divided by the standard error. So all this information is just coming from the table that we got from the question. So, I mean, except this, because we just assumed this. I didn't want to calculate that. It would take us a lot of time to calculate that. So I've just put a video. There's a video in my portfolio you can check out on how to come up with beta 1. So let's go on and just compute this on the calculator. So let me just get my calculator. So I want to enter the values. So we have so that is our t, the one on the calculator. So we just have to write it there, and we can just round it off. So, or we can put a h here, like that, just like so. So now let me just write well the 8. Someone might get confused. So here is a 7 and an 8 there. So from here, what we need to do is just to go for the last one. That is the last step, is just to make a conclusion. So we need to compare this, the t that we have found, from what we have. So if you remember, that drawing was like so. Well, this is too much. Let me draw well. Guess I can try though. I'm not good at this. Well, this at least somewhere. So this is a positive number, so let's just put 0.96 like that and forget about that. Then we just try to check here. So where is this one falling, the one we have found? Is it this side in the uh, acceptance region, or rather on the rejection region? So we can see that it's on the rejection region. So we can say this t, absolute value of this, is just greater than the critical value that we have, the t critical, like that, of of 2.67, like that. Then this one, we're just meaning is greater than 1.96, like that. So from here, we can draw the conclusion now to say, since this one is falling in the rejection region, is greater than the 1.96, so we reject the null hypothesis. Yeah, reject the null hypothesis, and therefore conclude that at 0.05 level of significance, the H is statistically significant. Let's work on the last question now. And our last question is, comment on whether the above conclusion in question F is consistent with the one obtained in question A using the confidence interval approach. So from our calculations, we can see that, yeah, it's consistent, because in both we rejected the H naught, which is null hypothesis, at this level of significance. In a single sentence, you can just say, yes, it's consistent at alpha is equal to 5% or 0.05. We rejected the H naught and calculated that H is statistically significant. Well, that's all for this video. Thank you.